Let's solve a physics problem about a jumping kangaroo. A kangaroo jumps to a vertical height of 1.65 meters. How long was it in the air before returning to Earth? Let's break this down into steps. The kangaroo's motion can be split into two parts, going up and coming down. Due to the symmetry of the motion, the time going up equals the time coming down. So if we find the time to reach maximum height and double it, we'll get the total time in the air. To solve this, we'll use the equation that relates velocity and position. V squared equals V naught squared minus 2gy. At the maximum height, the velocity is 0, and we know the height is 1.65 meters. Let's plug these values in. 0 equals V naught squared minus 2 times 9.8 times 1.65. Solving for V naught, we get V naught equals 5.68 meters per second. This is the initial velocity the kangaroo needs to reach that height. Now we can find the time to reach maximum height using another equation. V equals V naught minus gt. At the maximum height, velocity is 0 again, and we now know V naught is 5.68 meters per second. Solving for t, we get t equals 0.58 seconds. This is the time to reach maximum height. Since the total time is twice this value, the kangaroo is in the air for 1.16 seconds. To verify this makes sense, let's think about it. 1.16 seconds is about the time it takes to quickly toss something up in the air and catch it, which seems reasonable for a kangaroo jump of this height. Remember, we solved this by first finding the initial velocity using the position equation, then finding the time to reach maximum height using the velocity equation, and finally doubling that time to get the total time in the air.